Hello, this is Don with Mexsoft Corporation. Today we're going to be looking at Rhino3DPRINT 2016. And in this video, we're going to do the first in a series of 3 quick start guides. This guide will be working with point clouds. Here is a list of the tasks to be completed. First, we'll launch Rhino3DPRINT and open the point cloud file. Then we'll create a mesh from the point cloud. Then we'll auto-fix the mesh, refine and smooth the mesh. We'll analyze the mesh using curvature and reflection. We'll create and analyze slice curves from the mesh. We'll select a 3D printer and display its volume. We'll fit the mesh to the 3D printer and then check for errors. Then we'll organically grow a support structure. Finally, we'll export the mesh to an STL file and then generate a G-code file for the 3D printer. Okay, after you install Rhino3DPRINT 2016, you'll find a Rhino3DPRINT 2016 menu item on the main menu. If you drop that down, the first thing I want to talk about is the Welcome option. Select that, and the Welcome dialog will display. And what this gives you is links to resources about the product. Now, if you're not comfortable with working with videos to work with tutorials from a video, you can get this same quick start guide in a PDF document just by selecting that option, and it'll display the PDF document for you and you can work from there. Okay, let's close that. Also, from the Rhino3DPRINT 2016 main menu, you have the browser option. Now, the browser displays on the left side by default and contains all of the menu items you need and commands to work with meshes within Rhino3DPRINT. Now, the dialog is divided into 2 sections. The upper section, you have a ribbon bar where you have various commands that are grouped under the Create tab, the Model tab, the Inspect and Modify tab, a Repair tab, and a 3D Print tab. Under that, you have the data tree, where all of the objects you create are listed here. Then we have a browser toolbar below that, and then also an information window. Now, this information window will duplicate for the command dialog when you select a command. So let's get started and open the point cloud file. From the Rhino3DPRINT 2016 Quick Start folder, you'll find a file called rubberduck.csv. This is a comma delimited point cloud file. And if you can't find that file, just go to the file types and change it to points, and you'll see this rubberduck.csv file. Let's open it. Now, for the point input options dialog, you want to make sure you select comma for the delimiters and check the box to create the point cloud. Okay, here's our point cloud. Now, for this particular part, I know that it needs to be in inches, and if you look down here on the status bar, you see this is in millimeters. So let's change this to inches. Pick OK. Do not scale the model. Okay, now we're all set. Now, this point cloud was created from a physical object. It was scanned with a 3D scanner, and we have a series of points that were created. What we want to do is we want to create a mesh from these points and then eventually prepare it to be 3D printed. So the first thing we want to do is create a mesh from this point cloud. We have a command for that. So if you go to the Create tab, pick From Point Cloud, and then select the point cloud and right-click. Now, as I mentioned, the bottom half of the browser also is the command options area. And what I'm going to do is for each of these commands that we use, I'm going to read off what the options are, and then you can enter them on your end to achieve the same results. Now, from point cloud, for that dialog, we're going to use the multiplier value will be 2.5. The max number of nearest neighbors will be 100. The minimum angle would be 10. The max angle we'll use 120. For the maximum surface angle, we use 45 degrees, and then for search radius, we use 1. Okay, let's create it. Now, you'll see up here in the data tree that one mesh was created, and then we have our point cloud here. So we can turn the point cloud off for now. Now, one thing I'd like to mention here, as you can see in the data tree, each object has a checkbox. You can display or hide the object by checking the box or unchecking the box. And then also, if you, in your files, if you don't see the checkboxes, there's a command down here for toggle display of hidden objects. So if you don't see the checkboxes, just check this icon and those boxes will display for you. And also, you'll see over here we have the display properties tab. I have mesh wires turned on. If you turn them off, you won't see the mesh. So we're going to turn the mesh wires on, and then we're going to shade it to get a pretty good view of this mesh that was created from our point cloud. Now, obviously, you can see that the mesh has gaps and holes in various places. Now, when you open point cloud files, your may not have any problems, or the problems that you see may not be very noticeable. So a good thing to do right off the bat when you create a mesh from a point cloud is to do some diagnostics. So let's go to the Repair tab and pick Diagnose. Select the mesh, right click, and do the Run Checks. Now this checks for various inconsistencies in your mesh model. As you can see, there's all kinds of them. We have 1,234 open edges. That's the big problem because you got to have a closed volume to print a mesh to a 3D printer. So we know we've got problems. So let's close that. Now, luckily we've got a command in Rhino3DPRINT that allows us to fix these problems automatically. It's called AutoFix. From the Repair tab, let's pick AutoFix and select the mesh. Now what AutoFix does is it will analyze your mesh and it will fill any open gaps in the mesh, and it'll correctly orient all of the triangle facets on your mesh. So we select the mesh, right click, and let it do its job. So here we go. You see the holes in the mesh were filled in, and if you want to make sure that everything's filled in, you can go ahead and do another diagnose, select the mesh, and run the checks. Now, the biggie here, you see that we have no open edges. That's important. That has to be 0 in order to be able to 3D print your part. All these other items, we can fix those as we go along. So let's close that. So the next thing we want to do, now that we have a mesh, and it's closed, but it's not real pretty. It's uneven. Our meshes are all over the place. They're inverted. So let's see if we can remesh this and smooth the mesh out a little bit. So let's go over to the Inspect and Modify tab, and we'll select Remesh. Select the mesh, right click, and for the Remesh dialog parameters, we want to select the Uniform option, and we want to set an edge length to 0.125. So any facet on your mesh will be 0.125 long. And we'll set the number of iterations to 4. This means that iterations means that after it computes the first set of remeshing, it'll take that model and then remesh it again, and we'll do that a total of 4 times. So let's pick Remesh. So here we go. Now we look like we got some uniform mesh facets, but we still have some bumpy areas and it's not real smooth. So let's go ahead and smooth it out. Pick the Smooth command, select the mesh, right click, and for the Smooth Mesh options, we want to set the vertex shift direction. Now this is the direction that each vertex of each facet is allowed to move. And we're going to set this to both directions so they can move inward and outward. And that's all we need to set there. And we'll set the number of iterations to 4 and pick Smooth. Now you see we've got a really nice mesh. All the facets are uniform. The surfaces look smooth. Let's do some further analysis to take a look. On the Inspect and Modify tab, you also see that we have some inspection tools. We can do a reflection line analysis. Let's pick that. Select the mesh. And for the dialog options, we're going to set the line settings to a vertical, and then the number of lines to be 10 and the thickness to be 10, and we'll just render it. Now here, what this does is this puts a rendering on the mesh. It allows you to see any inconsistencies in the mesh, and it looks pretty good. So let's close that, and we can also do a curvature analysis. Select curvature from the Inspect and Modify tab, and we've got 4 curvature types. We'll use the mean option and pick Analyze. And what this does is it displays any curvatures in your mesh with a color-coded results. And we see, obviously, we have curvature in the beak and in the eye area and the tail and around the neck. Everything else looks pretty good. So we'll close that. Now, another cool command in Rhino3DPRINT 2016 is the ability to slice your mesh similar to the way the printer is going to slice it and print it. But what we're going to do is we're going to slice it and we're going to analyze the curves that are created. So let's go to the Model tab. We'll pick Slice, select the mesh, right-click, and for the slice parameters, we'll use 0.1 for the distance between each slice, and we'll pick Slice. Now you'll see that a slice object was added to the data tree. So now we have a slice object, we have the point cloud object that we turned off, and then we have our mesh. Let's turn our mesh off and just look at the slice. Now the important thing here to note in the dialog here is that it'll tell you if you have any open curves in your mesh. So if you haven't used the auto fix option or any of the repair options and you do this slice command, it'll tell you if any of your curves are open. And we have no open curves, so that's good. So we don't really need the slice curves anymore. One thing I would like to mention though is if you want to export these curves to actual curve geometry, currently it's just a display object. You can right click on the slice up here and pick export, and it'll turn them into curves for you. For now, we don't need the curves anymore, so let's select that and we'll just hit the delete key and that'll get rid of it. Now we'll turn our mesh back on. So now we've created our mesh, we've analyzed it, we've sliced it. Now we're getting close to getting ready for 3D printing. Let's select our printer. Down here on the browser toolbar, you have an option to specify your printer. So we select that. For the select printer dialog, we'll drop the printer list and we'll select, let's see, we're going to use the ShopBot ABS2. Now the ShopBot will accept G-code files and print them using their 3D printer. So we'll set it to ShopBot ABS2, and then also we're going to turn the printer volume on. It's got a little icon here. Let's view the entire part here. So now we have the printer volume is displayed, and obviously our part is outside of the printer volume. So we have a command that we can automatically fit that to the volume. So let's go to the 3D Print tab. We'll pick the Fit command. Select the mesh, right click, and for Z alignment we'll pick the center, and for XY we'll pick center. So we're going to center the mesh within the volume of the 3D printer. We'll pick Fit. Now we want to check this mesh to make sure that it's ready for 3D printing. We fit it to the printer, but let's also do a check. So we pick the check command from the 3D Print tab, select the mesh, right click, and pick Diagnose. Now we see up here in the dialog area, we see that the print volume of our selected printer is 7.5 by 7.5 by 5.5 inches. And it also tells you the volume of the mesh. Now obviously the mesh is bigger than the printer volume. So we're not going to be able to print it like this. And you'll see X's displayed here for areas that didn't pass the check. So the volume check failed, and obviously since the mesh is larger than the printer, all mesh is entirely within a printer volume check, that's going to fail. Now the good thing is all the meshes are closed, so we have a check mark there. Now these other two, thin walls, no thin walls lower than a certain value, we know we're going to have thin walls because we got a beak area here that's pretty thin. That's acceptable. And we know we're going to have overhangs. So you can specify an overhang angle, and it'll check your mesh to see if you have any overhangs. And those are displayed in blue, and you can see them on the part there. Now, we're going to reorient and probably have to scale this part in order to get it into our printer volume. Now the overhangs we're going to fix too, because we're going to generate a support structure for it. So let's close this. Now in the Rhino status bar, make sure your gumball's turned on. We'll select the mesh, and we'll select the rotate about the x-axis icon, and we'll enter -90 to roll it over on its side. And also what we'll do, let's change to a 4 viewport layout so we can see this more clearly here. Okay. Now obviously you can see that the mesh is too large for the volume still. We've got it laid on its side. Looks good on this side, but we've got to shrink it down some. So let's select our mesh, go to the transform menu, go to scale, do a 3D scale. For the origin point, we'll enter 0, 0, 0. We'll get it at the 0 world origin. Press enter. And for the scale, let's enter 0.85. So we're going to scale it down 85%. Now, with the mesh still selected, let's go to the 3D print tab, and we'll fit the mesh again. Z alignment center, XY alignment center, and pick fit. Now that looks pretty good. Let's do a check and make sure. Select the mesh, pick check, diagnose, and we see that it passes the volume check. All the meshes are within the volume, so we got a check mark there. And all the meshes are closed, and we got a check mark there. That's good. These two we can leave for now. So now also I want to point out here, in the overhang angle of 45 degrees, you can see in the bluey areas where we have the overhangs. And we're going to generate a support structure for that. So we'll close this. Let's go up to the perspective view tab and maximize that. So here's our part inside the printer volume. Now let's go and create a support structure. So from the 3D print tab, pick the support generation command. Select the mesh, and for the dialog options for support generation, there's quite a few parameters here, and what will be helpful for you to understand these parameters, you can pick the little help icon at the top of any command dialog, and it'll display the online help for that command. If you scroll down here, you will see a good illustration that shows you what these parameters mean. Now what the support generation command does, and it's really cool, it'll automatically grow a support structure from the base of your part down to the bed of your printer. And it's based on the overhang angle that you enter. So with this in mind, let's go ahead and set our parameters. With the overhang angle, we're going to set it to 45. For the maximum angle, and the maximum angle is the angle that the support structure is allowed to deviate as it grows its structure. We'll set that to 45 degrees. For the support diameter, which is the diameter of the support tubes that are going to be created. For the support diameter, we'll set it to 0.2. The sampling distance is critical. This determines the distance between any two branch points or support points on the overhang area of your mesh. So we're going to set that sampling distance to 0.25. We'll set the connector diameter to 0.1, the connector height to 0.5, the base diameter to 0.375. Now the base diameter and the base height, you'll see that from every branch, it's going to go down to the printer bed, and on the printer bed, it's going to automatically create a base diameter and a base height as a platform to support each of those branches. So for the base diameter, we're going to make it 3.375, the base height 0.1, and the base connectors on mesh. What this does is there may be areas in your mesh where the connectors can't get to the overhang angle or can't get to the base of the printer without actually passing through the part. And this will determine how you want to handle those connectors, whether you want to minimize any connectors on the mesh or you can disallow them. In other words, it'll have to avoid your mesh completely in order to get to the base of the printer, or you can allow them. And for this particular example, we'll just select the minimize option. Now, this dialog has 4 different tabs. Now, after you set the parameters tab, go to the support generation tab, and we're going to grow a tree type support structure. Now the tree type is what we have in the example here, where it grows out in a tree fashion and it'll branch off automatically to get to the overhang angles of your part. So we'll set it to tree and then we'll generate. And what you see here, and this is pretty cool, is it determined, let's turn the mesh volume, the printer volume off so you can see this better. It determined the overhang angles. This is a 45-degree overhang angle. So any overhang angle, it created the sampling distance points where your branch points connect from your overhang, and it organically grew a tree structure down to the printer bed. So now we're pretty well supported for 3D printing. Now that's a cool command. Let's turn our printer volume back on. Now, one thing you want to make sure, you have to actually generate the support structure. This is just a preview. And if you're interested in looking at seeing the tree, the straight tree, let's go ahead and pick that, and we'll pick generate so you can see it. So it just extends the tree, the support structure, straight down to the printer bed. I happen to like the tree structure because it's cool, so let's use that. So here's our tree structure for support structure. Now, there's other commands on here that you can experiment with. We won't do that right now. You can manually add and remove branch points if you think it needs more support in different areas. Let's go to the Details tab, and it calculates the volume and the length of your support structure. And then go to the Create Meshes tab. Now here, you can choose to add the support structure to the main mesh, and it'll be one mesh, or you can create a separate mesh. Now, creating a separate mesh has its advantages, because if you want to come back later and you want to delete the support structure, it's real easy to do. You just delete the mesh and you can regenerate another one. So let's leave it as create a separate mesh, and we'll create the meshes. So now what we see here, we see our support structure was generated for us in a separate mesh. If you go up here on the data tree, you see you have a mesh for the support structure and a mesh for the main mesh of our part. Okay, so we're done there, so we can close that. Now we have a part that is ready to be printed. We have a support structure that's ready to be printed. It's within our printer volume. It's passed all the checks, so we're ready to 3D print this part. Now, on the 3D Print tab, you have some different options. You can export the file to an STL file or a couple of other different options. Let's go ahead and show you that. Just select your meshes, right-click, and you'll see that you can export it to an STL file or a stereolithography SLA file or an additive manufacturing AMF file. For now, we'll just pick an STL file, and we have one there. We'll just go ahead and overwrite that. So we've exported it to an STL file. Now what we're going to do is, since our printer supports G-code, we're going to actually generate a G-code file to send to our printer. So from the 3D Print tab, we'll pick the Generate G-code command. We'll select our meshes, right-click, and this displays the Generate G-code options dialog. Now, there's quite a few parameters on this dialog. We won't go over them all, but I'll just tell you what we're going to use for this guide. For the layer height, we're going to use 0.05. We're going to have 1 perimeter passes. We're going to retract only between levels, and we're going to automatically calculate the extrusion volume of the printer. We'll have the top 2 layers and the bottom 2 layers will be solid. And for the infill density, now this is a closed volume part, so the entire part is going to be infilled. So for the density, we're going to use 50%. And for the fill angle, we're going to set it to 45. And for the top and bottom fill patterns, we're going to have a hatch pattern. And for the middle fill patterns, we'll have a hatch pattern. So let's generate. So it's going to calculate the G-code file and display it on the screen. Now, pretty much it's difficult to see what's going on here. So what we have here is we have a command down on this toolbar down at the bottom that allows us to look at the G-code by layer. So pick that, and the dialog will display that allows us to look at each level in the G-code file. So let's just scroll down through that, and you can see as you select a level, let's just deselect the mesh so we can see this better. As you select the level, it highlights on the part. And if you zoom in here, you can see that this is our perimeter pass and this is our infill in here. And these are our transfer motions here. So let's just look at it real quick. We'll scroll on down and you can see each level. Now you can go in and inspect each one of these levels if you want to. So now that once you're satisfied with the Z-level display, you can close that. And we still haven't created the G-code file yet. This is still in display mode. So we have to pick the Post button. And the Post and Save As dialog displays, and it will default to the folder where the part is located. And for the current post, we'll set it to shopbot G-code, and we'll set the file extension to .nc, and we'll pick Post. It'll calculate the post file and display it in Notepad. And what you see here, this is a G-code file. And what we have at the top is we have codes to turn the printer on, zero out the X, Y, Z axes. This sets your temperatures. If you look down here on your printer control parameters, you'll see that you have temperature specifications for the extruder. We have it set to 210. The bed is set to 200. For the speeds, we have the perimeter speed set to 60, the infill speed set to 60, and then the traversal movements set to 120. And you can see those values here. And then here's your first G-code line, and then your following G-code lines for each level in the 3D print. Well, that's it. I hope you enjoyed this quick start guide, and we got 2 more coming up, so stay tuned. Thank you. If you want more help with the product, you can visit us online at www.mexsoft.com. Thank you.